All right, so welcome, those who are just joining. Go ahead and say hello in the chat. Maybe let us know where you are zooming in from, and then we'll go ahead and get started. So actually, let me just move my controller over here and then go back. All right, how's my screen looking? Good. All right, hi Etta, hi Deanna. Nice. All right, so we'll go ahead and get started for today. This is drafting for Harness and Dobby Looms. So if you haven't already, we did send in the email, and Etta will drop this link in the chat. We do have a support handbook for these workshops. The handbook is really just intended to be a quick reference. So if there's something about the interface that you don't remember, it really just highlights some of the key concepts and interface features, with the idea that maybe you keep it to the side while you're watching this Zoom. We are also recording and archiving each of the workshops on our documentation website. So on the workshops and events page, you'll see that we've already posted the recordings for the first two workshops, which was getting started with ADACAD and then weaving imagery. So this is going to be our third and final workshop of this series. All of this has been supported by a National Science Foundation grant from the Pathways to Enable Open Source Ecosystems program. And so that's given funding for us to really focus on outreach activities around ADACAD and grow both the number of people involved in the community and those who are contributing as well. We are the Unstable Design Lab. On the call today is myself, Laura, who directs the lab. We also have Etta and Deanna. Etta, do you want to unmute and say hello?
Sure. Hi, I'm Etta. I'm a weaver and artist and a PhD student researcher working in the Unstable Design Lab. I first came to the lab as a weaver in residence, and now I'm staying on as a PhD student and supporting with ADACAD and this sort of like development of outreach and further community building through ADACAD. And Laura, just a quick note that I don't think we're seeing your slides right now. We're seeing ADACAD.
Interesting. Good to know. Okay, I will make sure I am resharing. Thank you for letting me know.
Yeah.
How about now? Perfect. Okay. So now you get to see what we look like. Deanna, do you want to say a quick hello?
Hello, everyone. My name is Deanna. I am also a PhD student in the Unstable Design Lab and have been working with Etta and Laura thinking about ADACAD and how we can reach broad community participation. And I specifically like to think about like what tools ADACAD can offer. So come from more of a computing background. So thinking about what sort of software can we do to make ADACAD even more expressive and offer more opportunities for people to make. So very excited to be here today and happy to help in the chat or jump into a breakout room if anyone needs any extra assistance. But yeah, happy to be here.
Great. I should also note in this photo, our two people on the ends, Netta and Lily, have graduated. So we'll have to be updating our photo, but we'll send a congratulations to them for finishing their various academic journeys for now, till we lure Lily back to the lab. All right, so for those of you who may not be familiar with ADACAD, we describe it as an experimental workspace that applies parametric design to the domain of weave drafting. We intend for it to support algorithmic and playful approaches to developing woven structures for cloth, for shaft, and for jacquard looms. So the workflow with ADACAD is a little bit different than other common workflows for designing for Dobby looms or for designing for jacquard looms, and that instead of sort of clicking individual pixels and filling regions with those pixels. We work in a more data flow style. So parametric design is this method of creating little digital workflows or digital machines that are flexible and that can change. So it's almost like writing computer code to generate drafts, but in this visual way. We run online at adacad.org, so you don't need to download anything. And we do have a pretty comprehensive documentation website available at docs.adacad.org. So if you're ever lost or you want help with a term, you can usually find it over there in the documentation website. Okay, so the follow along format is that we'll describe a set of features and concepts. So what we're going to do is like a call and response style workshop, and this is what we've done the last 2 times, is that I will kind of demonstrate a series of actions, and then I will give a prompt to the audience to repeat those actions. This is just to mitigate the need to actually watch and perform things at the same time. So feel free to just dedicate your attention to watching and following us, and then we'll give you time to do that on your own. So we imagine that you have ADACAD loaded on your screen and maybe this Zoom window in a corner. We encourage you to ask any questions in the chat while we do this. If you see a question that you also have, add a thumbs up. You can sort of boost that question in the chat. Etta and Deanna are doing a really great job of monitoring the chat and giving as much help as they can. If there's something that needs way more help than we're able to provide in the chat, we will open an emergency room, which is like a breakout room where you can go and discuss that one-on-one with Etta or Deanna. And after the workshop, you can always find support at our Discord. So Discord is like an online community. We have a channel devoted to ADACAD for Q&A and also just for other announcements and inspiration. I'm realizing I didn't update the second slide. I updated the learning objectives, but not the schedule. So ignore the schedule side for now. The learning objectives today is to really walk through the process of creating data flows that produce pattern threading sequences and treadling sequences using the pattern across width operation and the generate drawdown operation. So what I've come to understand is the traditional approach to creating woven drafts for shaft or Dobby or maybe jack looms is this 4-quadrant system where you have a threading at the top, a tie-up in the corner, and on the left or right side, you have a treadling or a lift plan. And typically we define these by individually clicking the pixels, and you can do this in ADACAD using the draft editor. So if you're in the draft editor, you can specify what kind of loom you have, and you can just click away, copy paste, and make threadings and treadlings that way. But there's also this way that we could do the same things using the data flow operations. So the 2 drawdowns you're seeing are equivalent, but they're created in 2 different ways. So on the right, we have a data flow that creates a drawdown by pulling different drafts into the make drawdown function. Why would we want to work with that? My personal opinion is that it has some advantages. For me, anytime I have to repeat an action in a digital interface, I immediately want to code it somehow or script it. And ADACAD kind of lets you do that, right? So if you need to define different blocks and repeat those blocks and be a little bit more flexible in the ordering of the blocks, that's something that a data flow can do really well. So this is just an example of some summer and winter blocks. And we're actually going to use this kind of example in our lesson today. Another thing I've enjoyed is using unusual threadings. So things we may not think of as threadings. Maybe you use some data patterns, maybe you use a sine wave as we have in our sine wave sample, and then plugging that in to generate different drawdowns in maybe more unusual or, yeah, not unusual, but new, playful kind of ways. And one of the ways that I've actually used it the most is I teach a course where we have 3 class looms. So I take each of the class looms and I create an ADACAD sketch with the threading and the color patterns. And then I invite students to explore different lift plans for that threading. So it gives students a way to kind of play around. This is an example of one of the students' designs and to kind of roughly simulate what might happen as a result of any given color combination in the weft and drawdown and lift plan. So today we are going to play with blocks. We did send this out over the email. I know some people prefer to print things out and work on them. But you're also, if you don't have that email or you're just seeing this for the first time, don't worry, you'll have everything you need. So what we want to start with today is really thinking about a threading pattern in terms of blocks. So this diagram is showing threading split into different blocks. And what we want you to do is assign each unique block a letter and write it in the corresponding space below the block. So if the block repeats, you assign that repeated block letter to the block it repeats. So for instance, if we call this first block A, we then identify all identical blocks also as A. So what we want you to do on your own, and we'll give you maybe a few minutes to do this, is figure out what letters we should assign to the other blocks and what this resulting letter sequence would be to represent this threading. Okay? I realize we need music here. Once you are finished, go ahead and throw a thumbs up in the chat, just as Teresa has done. All right, it seems like we've got some pretty good progress. And so to make sure we have enough time for the steps later, and with Edda's approval, Edda's my timekeeper, are we good to? Cool. So the correct sequence, or a sequence, there's actually multiple correct answers to this question. But the one I sort of came up with was this. So A, B, C, A, B, C, A, B, D, C. Does that look like what you all have? Any questions emerging at this stage? Cool. More thumbs up. All right. So now that we have this letter sequence, we're going to actually move over into ADACAD and start importing our blocks. So here's what we're going to do. Let me just shift my screen over. Okay. Are you still seeing ADACAD now on my screen? Great. All right. So actually, what's interesting, can you see ADACAD and my slides? Okay, so I'm actually going to pull up the blocks. So if we're looking at this, we actually see that there's 4 different repeating blocks, which we can call A, B, C, and D. And what I want to do now is create drafts for each of these blocks in ADACAD. So we're going to do this actually by not necessarily using the operations, though we could use some of the operations. It just might be easier in this case to do direct pointing and clicking. So I'm going to use this add draft feature. So when I click add draft, it asks me how many warps and wefts this draft will have. I'm going to do block A, which has 4 warps and 4 wefts. And that adds a draft to my screen. This draft specifically is called a seed draft because it doesn't have an operation that generated it. It is a standalone draft. Any changes we make to this draft can be fed into a data flow, but it will never be the outcome of a data flow. So it's always kind of the seed of the data flow that's going to grow. So what we can do now that we've added this draft is we can click on the draft cells to recreate our pattern. So if we have A, 1, 2, 3, 4, we can go ahead and just add A, 1, 2, 3, 4. The interesting thing to keep in mind here is that for ADACAD, a draft is a draft. It doesn't know yet that this draft is going to be a threading block. So it's going to let you do something like this, even though that's not a valid threading. What it's going to do is if you do define this as a threading, it's just going to pick the first one it sees. So for our purposes, we just won't add those little extra ones. We'll try to make this as correct as possible, but I wanted to just let you know that's a possibility. So what I'd like you to do now is add the remaining 3 drafts, okay? So using the add draft feature, go ahead and add in drafts for these 4 blocks. And we'll give you a minute or so to do that. So good question from Teresa. I think, you could represent them either way. For our purposes today, we're going to treat the wefts as though it's corresponding to the number of frames. So we're going to assume we're using a 4-shaft loom. So I would make each of those drafts 4 wefts, and then just fill in the draft like it's shown here. Okay, so while you're doing that, I'm also going to do it on my screen just to make sure that I'm ready for us to do the next step. One thing I like to do here is just double click and say duplicate, so I don't have to start it all over again, and then just change from there. And let's see. Okay. All right. Are we ready to move on? Etta, I'll use your cue here. Cool. All right. So one thing Etta did point out in the background is that there is a feature to name the different drafts. It is super buggy, so I wasn't going to show it, but I intend to fix it in the future. So if I click on a given draft, oops, seem to have lost my, here we go. And let's see. I can come down here and give it a name. So like that would be B. And then you see it says B there. I can switch over here. It's being a little weird right now. So I'm not going to follow up that process. But in the future, I hope to make that a little bit more streamlined so that you can name the draft. All right. So our next step is that we're going to take these blocks and we're going to put them in a sequence. So just like we have them in a sequence over here, we're going to repeat that sequence in ADACAD. So we're going to do that using an operation called pattern across width. This operation lives in the section of operations called cloth. So all the operations that are intended for arranging structures next to each other are found in the cloth section. And here you'll see we have pattern across width. We also have pattern across length, though since we're working with the threading, we're just going to focus on the width today. So what this pattern across width operation does is it takes a letter sequence, A, B, C, for instance, and it creates a series of inlets for each of those letters. So if I were to connect A to A here, and B to B, and this draft to C, you would see that it would arrange them A, draft B, draft C, draft A, draft B, draft C. So what I want us to do here, and what you'll do just after me, is we're going to replace this pattern string with the one from our threading. So that was A, B, C, A, B, C, A, B, D, C. And you'll notice that I put spaces in between each letter. Those spaces are really important because if you don't have them, ADACAD will just think it's one big block of letters. It won't know to treat them as separate things. So we add everything in with a space between it. We hit this regenerate tool, and now you'll see that we have a D, right? We didn't have a D before. So I can add in our last draft to D. And you should notice that this looks identical to the draft that we derived in the beginning. So that is your next task. Go ahead and add pattern across width, add the same letter sequence that you see here, and connect your drafts. Okay, so we'll give everyone a minute or two to do that. Give us a thumbs up in the chat when you are done. Okay, we good to move on to the next one, Etta? All right. Any questions emerging from the chat before I move on? Okay. One thing I realized I didn't mention earlier is that we are recording these sessions. If you do have any issues or any feelings about being recorded, please feel free to just write us in the chat and we'll edit any mention of you or any video of you that appears out of this. The videos historically don't include the audience, but I'm sorry, I should have announced that earlier and I forgot. So yeah, just let us know if that's an issue for anyone. We're happy to accommodate. Okay, so the next step that we have after pattern across width is we have a threading now, but how do we actually take this threading and make an interesting drawdown from it? I'm going to sort of preface where we're going, and then we're going to do a few steps in order to get there. So in our operations, and also just as a reminder, in order to use these features, we have to enable the advanced operations. So if you're not seeing what I'm seeing, go ahead and make sure you're seeing advanced. You can scroll all the way down to the bottom here, and we have this maybe not amazingly named category of operations called drafting styles. What these do is these work in two ways. They either dissect a drawdown into a threading and tie-up, or they take a threading and tie-up and treadling and create a drawdown from it. We have two different approaches. If you're using a Dobby loom, you can just give it a lift plan and threading, right, to generate a drawdown because the tie-up is assumed to be 1-to-1. And if you're using a harness or a floor loom, you would have to provide the threading, the tie-up, and the treadling pattern. So the one that we're actually going to use today is this bottom one, make drawdown from threading, tie-up, and treadling. What I want to also maybe call attention to is that when we add these, maybe you don't totally know what this operation does. If you say view options or you double click this header, you can always click help and that will open a window with the documentation. So this will at least give you a little bit more context of how this operation is used. So we have this make drawdown. This is going to generate a drawdown if we provide it all the information it needs. Right now we have a threading, so we can go ahead and connect that threading in, but we do need a tie-up and treadling. So the first thing we're going to do as a group is make a tie-up. So given that we're assuming our loom has 4 shafts, and let's go ahead and just say it has 4 treadles. We're going to add a draft that is 4 shafts by 4 treadles. Then we can design whatever we'd like our tie-up to be in this seed draft and connect it to the tie-up inlet. So go ahead and take a minute, create your tie-up using the add draft and connect it into the tie-up inlet on make drawdown. So maybe I'll rewind a little bit. Add the make drawdown operation, connect the threading, add a tie-up, and connect the tie-up to the operation. Does that sound good? We'll give everyone a minute. And again, as always, just add a thumbs up in the chat when you are done. All right, thanks everyone. So we're going to repeat the process now, but for the treadling. So there's a lot of different approaches we could do to make the treadling. So for instance, we could go back, we could create different treadling blocks and then arrange them vertically with pattern across length. But one thing that I like to do is replicate what I think I've been trying to learn. I'm going to just confess, I am not an expert at profile drafting. I am trying to learn by following all of the activities in this lovely book. And I believe she calls this as drawn in, when your threading and your treadling are sort of mirrors of each other. And we can sort of achieve that effect with a little bit of a hack with the rotate feature. So I'm going to go ahead and add the rotate operation. I'm going to set it down here to the left of my drawdown, just because that's where I usually do my treadling. I'm going to take our threading and I'm going to connect it to the input of rotate. And that's just going to take the threading and rotate it 90 degrees. If I want to rotate it the other way, I can select 270. So when I have my rotated threading, that can function as a treadling. I'll take the output of that treadling and add it to my treadling. Treadling inlet, and then you can see the result in the drawdown, I think. Let's go ahead and try this again. Okay, so I'm going to go ahead and give you a chance to work on the treadling. Oh, yeah, this is kind of a weird. There. All right, so just to be totally clear, your job now is to rotate the threading to create a treadling and connect that rotated threading slash treadling to the treadling inlet of the drawdown and throw in a thumbs up when you're done. And as always, questions are totally welcome. And given that we have a small group, if you just want to unmute and ask the question, that's totally fine as well. All right, how are we doing? All right, I will keep moving on. Again, if questions are coming up, please feel free to drop them in the chat. The thing I wanted to show now is we can play. So what I really enjoy about this is now we have a whole data flow set up around a kind of parametric workflow for assigning blocks to a threading and then seeing what that drawdown would be. You can go ahead and change different elements of your tie-up and see what happens, see how that results in the drawdown. You'll notice that when I click on the operation, it shows, a rough simulation of the cloth in the sidebar here. But every time I click away, I see a different feature. So what you can actually do is just pin this view to the viewer by hitting this pin button. And now everywhere I change, I will still see the updates in that big window as well. So I can also kind of use this to see like, oh, I have a huge warp float. I should probably add in a binding somewhere and a weft float and something there. There we go. There we go. We can also go in here and change the letter sequence. So maybe we could say A. We can add another B, we can add a C, and maybe some D's in the middle. And as long as I hit regenerate, you'll see that the entire draft is updated. This draft is a little bit noisy, so I'm going to go ahead and change my TIEUP. Okay, any questions coming up so far? Oh, another fun thing is that you can actually change your threadings too, right? So we could maybe remove that one and go over here, see what effect that has. The last step that I wanted to, actually there's two more small steps. One is just the ability to simulate different color sequences. So we've showed this in our first workshop, but we'll show it again now because it could be relevant in this situation. But if we scroll down our operations list to color effects, there's this operation called set materials and systems. So we can add this. We can take our drawdown and connect it into the draft of this operation. The next inlet of this operation is expecting a draft that has some kind of color information. And it's going to take that color information in some kind of reduced form. So what I'm going to do is go ahead and add another seed draft. And let's say I have a single color warp, so I'll say 1, but I want to alternate like a color sequence of 4 in the weft. So I'll add this 1-4 draft, and then if I click in this color region here, I can cycle through the predefined color set that ADACAD gives you. So let's say I'll do red and yellow. This is a very German color palette. Then I can click and add that into systems and materials. If I unpin this and click this draft, you can see what that color sequence does. If I wanted to change this color sequence, I could always double click, open it in the draft editor, and change it here as well. So maybe I could add in, 3 more warps, and I could give them white and red. Okay, and then I go back to my workspace, and now this is updated with that color sequence. So this is, it's kind of interesting. Cloth can be a little hard to look at times. But let's go ahead and take a minute and add your own color sequences. All right. So the task this time is to add the set materials and systems operation, connect your drawdown to the draft inlet, and then create a color palette seed draft that you connect into systems and materials. And if you're feeling fancy, you can share your outcome to the chat as well. Nice. Yeah, so adding the colors can be nice also, like let's say you already have a warp on your loom and you already have a threading, then you could really play around in this treadling or lift plan area and just explore what other color mixing possibilities would emerge there. Maybe I'll give everyone one more minute to play with this, and again, please feel free to unmute or ask your questions in the chat as they're coming up. Ooh, nice. Yeah, I'm always fond of the drafts without color. I always kind of fall in love with the black and white. Um, yeah. Yeah, and what's interesting, sometimes when I see a draft, like, oh, I just really love this draft and I would like my cloth to have some pattern like this draft. This is a tangent from our like regularly scheduled workshop, but what I like to do is use the stretch feature, which basically like will take this drawdown and just stretch all the warps and wefts. And then I can add a fill, and I can fill all the black regions with, let's say, a warp facing structure, and all the white regions with a weft facing structure. So do that here. Yeah, so then you would get something, oops, unpin. Whoa, yeah, so that kind of makes it into something different, a little more checkerboardy. Okay, so the last step I want to show, and then we'll open it up to the Q&A, is just another variation that I like, another way to be playful and maybe just experiment. So I'm going to pin this draft to the viewer, but what I'm actually going to do is I'm going to replace my tie-up here with a operation that we generated in collaboration with Marianne Fairbanks. So Marianne was really interested in like mathematically determining how many valid structures would be possible with a given number of shafts. So for instance, if we have 3 shafts, our drawdown could look something like this, or this, or this, or this, or this. What's interesting is when we go up to 4, there's like 15,000 different possibilities for what this could be. And one way to think about this is like cycling through every possible tie-up for a 4-shaft loom. So what we're going to ask you to do here is actually go in and add the all possible structures operation, change the size to 4, and then swap out the tie-up that you had with the all possible structures. And what you'll see here is it's generated us a new draft. I'm going to go ahead and just pin this one back in the viewer. And then as I cycle through these, I can see all the different structural or color variations that come from the different tie-ups. So again, just another way to like sample and explore in the space all the possible variations that could come just from changing your tie-up. So that'll be our last activity for today, and then we'll open it up to the Q&A. I'll give you all a moment, but if you want to play with your all possible structures in your tie-up, go ahead and add that in there. And again, maybe play around until you find a color pattern or a structure you like, and share it with us in the chat.